hosted by GADRRRRES in collaboration with UNESCO and the UNESCO Chair on Intersectoral Safety for Disaster Risk Reduction and Resilience at the Safety and Protection Intersectoral Laboratory of the University of Udine in Italy, as well as with the support of Save the Children. Today, we are very fortunate to be joined by 3 presenters. Our first presenter is Dr. Jair Torres, who is a senior consultant on disaster risk reduction, resilience, sustainability, and adaptation, as well as the founder of Sustainability, Adaptation, Resilience Global Consulting. Dr. Jair Torres holds a PhD on risk and emergency management from the Understanding and Managing Extremes Graduate Schools of the University School for Advanced Studies, IUSS in Pavia, Italy. Dr. Jair Torres has been working as an international consultant on disaster risk reduction, resilience, sustainability, and adaptation for different United Nations agencies, governments, universities, and academic institutions, as well as NGOs and private sector companies. Dr. Jair Torres has especially provided consultancy services to the International Hydrological Program, the Intergovernmental Oceanographic Commission, and the Unit for Disaster Risk Reduction and Resilience, which are all based at UNESCO, but has also provided consultancy services to the University of Udine, to the Global Alliance for Disaster Risk Reduction and Resilience in the Education Sector, the International Network for Multi-Hazard Early Warning Systems, and different governments worldwide. Our second presenter today is Professor Stefano Grimas, who is the chairholder of the UNESCO Chair on Intersectoral Safety for Disaster Risk Reduction and Resilience at the University of Udine in Italy. Professor Stefano Grimas is the director of the Safety and Protection Intersectoral Laboratory at the Polytechnic Department of Engineering and Architecture of the University of Udine, where he is also a professor of engineering seismology and of safety and civil protection at the master degree courses of engineering. Professor Stefano Grimas carries out research on safety and emergency management with a holistic and intersectoral approach for developing multi-hazard safety assessment and decision-making support tools. He is also a scientific consultant for national and international institutions and organizations working in the fields of safety, disaster management, and resilience. He is finally the author of more than 150 papers in the field of industrial, civil, and territorial safety and risk prevention. And last but not least, but our third presenter is Dr. Petra Malisan, who is a researcher at the UNESCO Chair on Intersectoral Safety for Disaster Risk Reduction and Resilience Sprint Lab at the University of Udine in Italy as well. There she achieved a master's degree in civil engineering, as well as a PhD in environmental and energy engineering science. Her research focuses mainly on the definition and application of vulnerability-based methods for risk and safety analysis of public facilities, and on the VISUS methodology in particular. Dr. Petra Malisan designs and develops tools aiming at simplifying the multi-hazard safety assessment pre- and post-event, and supporting the capacity building of users. Dr. Jair Torres, Professor Stefano Grimas, and Dr. Petra Malisan, it's a real pleasure to have you join us today. At this point, we will hear from you for 1 hour presentation before having a 20 minutes questions and answer session. I will therefore hand over to Dr. Jair Torres, who will start the presentation. So Dr. Jair Torres, the floor is yours.
Thank you, Lucille. So we are uploading the presentation now. Okay, good. So I guess that everybody can see the presentation right now. So just to you to see my face that I'm not a robot here. So I would like you to see me a little bit. And okay, as after the introductions, we would like to go directly to the VISUS methodology webinar. So we're going to have this presentation divided on 3 parts. We're going to give a brief introduction about why this methodology, in which kind of framework it is inserted. Then we're going to speak about the methodology itself and the different technologies that we have for implementing it. And then we're going to talk a little bit about where we have done it, how we have done it, and how you that are listening to this webinar can take advantage of the methodology in order to implement it in your programs at the country level. So I'm going to turn off the camera like that. We're going to use less, we're going to see the presentation and that's it. So, okay, so just going to move this. So for the presentation, okay, so as I say, we're going to have the introduction of the VISUS methodology. Then we're going to learn a little bit more about VISUS, about why, how, and what. This is going to be prepared by Professor Grimas. And then Professor Marizan will talk about how VISUS works. And then we're going to have an overview of the worldwide VISUS pilot projects. So, for the introduction. So, as you may know, school safety has been linked to the major frameworks of the 2030 Development Agenda, notably the Sustainable Development Goals, the Sendai Framework for Disaster Risk Reduction, and the Paris Climate Agreement. Not exclusively to these three. For instance, in the Agenda for Humanity, on the agreement of the Addis Ababa framework for financing development, there are also mentions about the need to protect critical infrastructures, notably schools and hospitals. But it's very important to know that under the Sustainable Development Goals, SDG 4, that is on quality education, has a specific topic on the need to secure safe schools or safe school environment for everybody. And that in that specific SDG 4A, we are talking about the specific need to have regular assessments and to secure that this critical infrastructure is well. In the Sendai framework, we also talk about the strategic infrastructures. We talk about the schools, about the importance of understanding the different risks that all of them has. It's vulnerable, exposed to, and also about the needs to improve governance and to secure good investments in the area of critical infrastructures. Same on the Paris Climate Agreement. We talk about the need to assess the potential exposure that different critical infrastructure will have due to the climate variability. So as we see, schools are very well mentioned in the whole 2030 agenda that is leading our development nowadays, and the compromises of governments worldwide. So it's in this sense that the Global Alliance for Disaster Risk Reduction and Resilience in the Education Sector, which is an alliance chaired by UNESCO and UNICEF, and that has many very important partners worldwide, such as UNDRR, GFDRR, Save the Children, and those that you see on the screen, has been working on defining what is school safety, and also trying to provide tools and methods and guidelines that will support practitioners and policymakers in implementing the necessary actions for securing that every single school is a safe school. It's in this sense that this Global Alliance launched the Worldwide Initiative for Safe Schools, which has the global commitment to school safety of more than 60 governments all around the world. And that is expected that from here until 2030, most of the countries worldwide will commit politically to start working on the different elements of school safety. Those different elements has been defined on what we call the Comprehensive School Safety Framework. How we call it CSS. It's the composition of three main pillars. The first pillar is about safe learning facilities. So we are talking about safe site selections, building codes, performance standards, disaster resilient design. So everything that is more related to the science behind school safety. So everything that comes from the science, from the research, that will support that we build good schools in good places that are the less exposed, and with materials that will make the schools the less vulnerable possible. So we are talking about everything that is construction, but also risk assessment, site selection, and we are discussing here about all the elements that need to be implemented to secure that the learning facility is safe. The second pillar is about school disaster management. So it's about how we deal at the school level with emergencies, how we prepare for them, how we react to them, and how we recover from there. So this is the need to have to make continuous drills, to have a good planning, to know a recovery, to have a recovery plan, to have a family reunification plan, to have all the necessary to be sure that we are prepared and can absorb a specific hazard, and that the education sector will go back to their activities as soon as possible. And the pillar 3 is about risk reduction and resilience education. So this pillar tells us more about trying to understand how a hazard can become a disaster. So trying to understand the drivers of what make a disasters, and trying to understand, for instance, what are the different elements of natural hazards, how a volcano is built, what an earthquake is, how it's produced, etc., etc. It's about learning education and about everything that is needed in order to understand what is a natural hazard and how natural hazards or technological hazards or anthropogenic hazards can become disasters. In the middle of these 3 pillars, we have multi-hazard risk assessment. That is one of the areas that we want to discuss today. Education sector analysis, which is very important because we cannot implement this if we don't know what are the elements that are already established in the education sector. And child-centered assessment and planning. So the importance to put kids in the center of the whole interventions for school safety. And this, if you see this framework graphically, has a very important call for coordination. So the education sector policies and plans need to be aligned to the national, subnational, local, and disaster management plans. This is in fact because we have ministers of education or national disaster management offices that needs to work together in an harmonized way in order to secure that the different elements of the 3 pillars are being implemented in a coordination manner, because that can generate a lot of conflict if there is not very well harmonized. So, saying this, also, as you saw in the center, we talk about the multi-hazard assessment. And this multi-hazard assessment, the Global Alliance has produced different tools that help practitioners, communities, decision makers, and at the end, constructors and builders to get a better understanding about what are the physical vulnerabilities, and not only physical vulnerabilities, but in the other 2 pillars that we will have on the school. So we try to assess with these tools not only the facilities itself, but also how the people understand the risks that are present in the community. Also to have a self-assessment about what we believe that is a problem in our school concerning the 3 pillars. And we have VISUS that is dedicated notably to pillar 1. And also we will have more detailed kind of assessments. So for instance, if you see here, the first level of assessment is what we call the first step, that is a community awareness. RISRECT, that is one of the members of the Global Alliance, has developed a mobile application that allows education community, professors, students, teachers, members of the community to try to to approach themselves to the comprehensive school safety framework in a very pragmatical way. It's more a tool that helps us to raise awareness within the community about what is school safety, about how communities can interact in securing that we're going to have safe schools. The second assessment that has been proposed by Save the Children and that has been implemented in Laos and in Fiji is what we call the CSS School Self-Assessment, that is internal assessment, that is focused also on the 3 pillars, and is a mechanism on which the schools themselves, so a committee from the schools, or where you will have the professors plus the principal of the schools, will do a self-assessment of every single pillar of the comprehensive school safety framework. These are preliminary assessments that help us to better plan later and to get some information about how the school is doing related to education, how the school is doing concerning to management, and notably to have a preliminary information about how the people that are in the schools see and understand the infrastructure on where they are staying most of the time. And then we're going to have the VISUS methodology that is focused notably on pillar 1, but that has elements for pillar 2 and 3, and that has a more in-depth inspection of the schools in terms of the potential vulnerabilities or the potential impacts that any kind of hazard can produce in the schools in a multi-hazard perspective. We're going to go on that later on. And then you can have more detailed investigations and design analysis. For instance, enterprises like ARUP, that is also a member of the Global Alliance, they have developed in-depth methodologies that will allow you to go and analyze the building with a more detail. But the question here, all these levels of assessment is because we have limited resources. So why we need to do detailed assessment to all of the schools in the world when we can get some information provided by the community, provided by the school itself, and inspected by trained surveyors, and only dedicate some of the resources that we have for those schools that we have identified that really require a more detailed investigation. We're going to go back on this because it's very important to try to understand one of the concepts that are important on the VISUS methodology, that is the concept of triage, and the importance of the VISUS methodology to assess huge numbers of schools. So this is one of with the VISUS methodology, we are trying to diminish the limitations that governments will have concerning inspections on site due to the level of detail that sometimes was thought that was required, but with a more efficient way to do it, using the resources that we have at the national and at the local level, notably on technical and academic institutions. So this is kind of an introduction to why we are doing this VISUS and where it is. Just to give you one example, when I was talking about resources, Japan is one of the countries that we consider one of the most prepared in terms of disasters. It's a country that is exposed to a number of hazards, notably seismic hazards, tsunami hazard, volcanoes, floods, etc., etc. But one of their main issues is related to the seismic hazard. So therefore, in 2000, in the year 2000, the Minister of Education of Japan started planning for an assessment to the whole schools that they have in the country. They have around 100,000 in 2016, they have around 100,000 schools in the whole territory of Japan. And they developed a detailed assessment to all of the schools. And this took around 15 years. So it took 15 years to assess only to the seismic hazard all the schools in the country. This in a country that has the economic resources to do that and the technical resources to do that, because as most of you know, one of the most important institutes on building is the Building Research Institute of Japan, which is linked to the Minister of Land and to the Minister of Education supporting that. So a country like Japan spent more than 15 years assessing all the schools in a very detailed way, but they have all the resources, technical and economical, to do so. But the problem nowadays is that, we live in a world that unfortunately doesn't have the technical and not only the economic resources like Japan, and that doesn't have so much time, like more than 15 years, to assess all the quantity of schools. And we are also talking about different countries on which one you have different limitations, for instance, geographical limitations, in order to try to assess all the schools in a very detailed manner. So this is one of the elements that came to us and said, look, we need to have a standardized methodology that can be applied in a more efficient way and that can go to many schools in a real short time of time. But passing from Japan, I want also to show you a little bit the world that we face, where we say, and this is the study case of Haiti. Before in 2010, before the earthquake, most of the investments on the education sector and in other sectors in Haiti were done without put in the perspective of disaster risk reduction. So a lot of the investments, for instance, on schools were done without following any kind of building code or any kind of guidelines or regulations. Site selection was not the rule, and many issues that nowadays for us are very evident concerning the need of a good site selection, following specific standards for schools, were not really implemented, and was more on the basis of the donor interest or the sometimes individuals that were pushing for these areas. But in the earthquake of 2010, we realized that most of the educational infrastructure suffered because it was not very well built, because they didn't follow any kind of codes, or because they were built in the wrong areas of the country. So since 2010, we understood in Haiti that we need to take into consideration seismic hazard. And since 2010, many organizations, many NGOs, many people coming from the donor community, many people coming from the private sectors, but even the UN start building a lot of schools in Haiti in order to be seismic resistant. But we never saw the possibility that not only seismic was affecting the schools in Haiti, and we have other hazards that were affecting the island. And we realized that very, very negatively after the impact of Hurricane Matthew on 2016, where almost 50% of the new schools that were built since 2010 collapsed or were damaged because they were very well seismic resistant, but they were not hurricane resistant. So we have some lessons that we learned since that. So the first is that we need to provide policymakers with decision-making information that led them to take decisions, and that give them all the necessary information concerning all the schools, the inventory, where are they located, where are they, based on their locations that are exposed to which kind of hazards, and what are the physical vulnerabilities that they have right now in order to start implementing strategies. The second is that we need to have an approach that will be in a multi-hazard perspective. We cannot go only on one hazard approach because we are facing many different hazards, and climate change is pushing for many of them to be combined. So we need a multi-hazard perspective that allows us to do interventions in a more efficient manner, in a more efficient manner, and that are really covering the whole hazards on which one school can be exposed. And the other thing that we realize is that countries with low capacities in terms of financial and human resources urge to potentialize their existing limited capacities. And we understand this because working on Haiti on implementation of VISUS, we realize that even if we believe that they don't have some very advanced technical capacities, the universities there, they do have it, and their students and their professors, they were very, very aware about the different vulnerabilities that the school have and had a good perspective. So you can use really the local capacities in every single country to really perform an assessment if you have a standardized methodology. That is what we are proposing here. So what we are doing now concerning this physical environment. So through VISUS, we are trying to understand why a school is vulnerable, physically vulnerable, how we can intervene, and what will be necessary to implement that in that schools. And when we are talking about the physical environment, we are talking about the location where that school is. So what are the kind of hazards that will affect that school? We are also checking not only the location, but also the buildings, either the major buildings or the annex buildings that can also affect our school community. But also we need to check the schoolyard, because buildings, the built environment is not only about walls. It's also about where the kids are passing most of the time. And sometimes we see in some schools that maybe the building is very well built, has been following all the codes. There is not an issue with the building itself, but the green areas or the common areas where the kids go and play, present some kind of issues that can compromise their security and their safety. So these are the elements that we try to analyze, not only from the engineering perspective of the building itself, but also from the perspective of safety of the kids in the schools. And this is with the idea to have life safety, not only of children, but also the educational community in the school, so the administrative people, the teachers, etc., etc. Also to secure education continuity activities. You know that the right of education is one of the most important on the scale of rights. So schools needs to be very well prepared in order to secure that we're gonna lose the less of days in education activities. And the third one is concerning loss prevention. So we know that we have very limited resources in our Ministry of Education. So what we need to do is to secure that every dollar invested by the Ministry of Education is a safe dollar invest, so that we don't need to lose money that we need. So we need to invest in a good and proper way, either on building new schools or on retrofitting those that are a little bit not good in terms of safety. So what would happen when the number of schools is very large? So the decision makers' concerns is to first understand what is the situation, what is the safety situation in each learning facilities, which schools need priority interventions and why, and what types of interventions are needed, and how much will the cost of these interventions be in order for them to start planning and to know how many interventions are required and on which areas they need to focalize these specific interventions, knowing the limitation of budget that they have. Notably, when you have all this information to plan, it's easy for you to communicate the risk to the community and to develop an action plan that will be easily negotiated with the Minister of Finance or with the donor community in countries that really don't have this kind of resources. So we are giving elements that will provide decision makers with all of the information that they require in order to negotiate with their counterparts at the country level or at the regional or at the international level. So this is, in a way, what we are trying to provide to decision makers through the application of the VISUS methodology. So it's in the sense that together with the University of Udine, UNESCO launched the preparation of these guidelines that are discussing about the VISUS methodology. The guidelines are divided on 3 volumes. The first volume is a volume that is focusing, that is target or addressed to decision makers in order for them to understand what are the different commitments that their governments have signed and how these kind of policies interact in their development plans, strategic plans for disaster reduction, for climate change adaptations, etc., and how they can use the information that we are providing with the VISUS methodology for their planning and for instance, to linking it with education management information systems. The second volume will talk about the methodology itself, so the science behind the methodology. This is what Professor Grimas will be presenting after me. And the third volume will be about how you implement this, how you prepare yourself at the country level in order to secure a good and swift implementation of the VISUS methodology at the country level or at the local level. So saying this, now I'm going to pass the floor to Professor Grimas, who will explain the why, the how, and what about the VISUS methodology. So Professor Grimas, the floor is yours.
Thank you, Jair. Hello to all of you from UNESCO Chair of University of Udine. We are together, me, Stefano Grimas, hello, and Petra Malizan.
Hello.
Just to show our faces, and now we go ahead with the presentation. So, starting from the final consideration of Jair regarding why we propose the VISUS methodology, the concern that the decision maker have to face in order to resolve the problem of safety of school at territorial level in multi-hazard prone areas, I want to stress in my starting point is that the decision maker need to manage the problem. This means that they have to know which school they have to upgrade first in terms of priorities, why and what is needed for in terms of intervention, and also it's important to know the cost of the intervention. And finally, how define the strategy for a cost-effective action plan. First of all, there is a first important observation. There is a difference between two main problems. There are two main problems: the new building and the existing buildings. There are different aspects that we have to consider in these two problems. If we consider the new single building, through the building codes, we create during construction the good characteristics in terms of control of risk. If we face the problem of existing building, we cannot use directly the building code, but we need to assess the situation and also to define the criticalities and the vulnerabilities in order to prioritize the intervention and point to the risk reduction as a final result. This means that we cannot transfer the approach of the new buildings to occur in the existing building approach. The second observation is that if we need an assessment, a preliminary assessment, we use part of the money that we invest in this process for making the assessment. So this means that we need to reduce as much as possible the use of money in order to use this money in the real intervention on the buildings in order to improve safety. This means that we have to find a methodology that permit to go fast, but that permit to know how much is enough in order to define what is opportune to do. In order to resolve this problem, the idea that is behind of VISUS is to make a sort of analogy with the disaster medicine. Jair has already mentioned the concept of triage. Triage is a methodology used in the disaster medicine in order to routine the patients in terms of treatment when the number of patients are high. The idea is to create this analogy between the patients and the buildings, in this case the schools, and create a sort of process that permit to make a very rapid assessment on the school complex. And just to show you that the parallelism in the medical sector, the patient arrive at the triage point where usually a nurse make the triage. This means that it's not a specialist in terms of, it's not a doctor, but is a nurse that is trained, that is able to make the triage and define the prioritization and characterization, and then route the patient through the pathway that permit to obtain the final treatment of the patient. In the same way, we can do the same process if we consider the building, the school buildings, in which if we train a surveyor, like the nurse in the medical sector, is able to create a first evaluation that permit to address the right treatment for the specialist, in this case engineers, in order to make the final intervention for upgrading safety. So this means that the triage is a sort of middle level between the desk analysis and data mining, what, for instance, Jair explained before about the CSS suite, and the last level, that is a detailed investigation and design when you are facing the single building, and you go with the final result. Triage permit to define a sort of knowledge that permit to define the action plan in terms of safety, weakness, characterization, intervention needs, identification, budget allocation that is necessary for face the problem, and all of these elements are the elements for decision making using multi-criteria and definition of the best strategy, taking account also the characteristic of the country. This means that in this parallelism, through the triage, and VISUS is the method, like in the medical sector, it's possible to define some graphical indicators that permit to define the priority, the problems, where the problem is located, and give through, for instance, the stars, in this case, final global evaluation of the safety situation. This permits also, during the process, to address directly the treatment necessary for the single school assessed, defined actions for facing the problem. This process has been created using the knowledge of experts, like in the medical sector, the nurse, when make the triage, use the knowledge of the doctor, the specialist, in a very simple way through a series of algorithms precodified using the precodification of the expert reasoning. We use the same approach, this is a more scientific part, using what is called the Pareto principle, that means that the 20% of the parameters define the 80% of the solution. This means that is necessary in order to go fast is to define the main aspect that permit to know the problem. Then if we define a sort of automated process that permit to use the input collected by the triage and the expert reasoning, is possible to obtain in automated way the output. This permits also to have a uniform judgment of the same situation from different surveyors. So just an example. The first problem that we have to face is what is necessary to assess if we consider the school complex. School complex is composed by the site, the building, the facilities, and the schoolyard, the external part of this building. The main aspect that we have to face is, first of all, the structural aspect of the building, mainly the main buildings, but also the ancillary buildings. Another aspect are the some local problems in the structure that can produce some hazard for the children. And we have to consider the non-structural elements internally and externally of the building, but also the functional aspect. In this case, in the picture, you can see the problem of the egress system that after the collapse of the ceiling is blocked, and this avoid the possibility to go out after the event. So also the problem of functional aspect are important in terms of safety. But last but not least is the problem of the location. In this case, we have two pictures in which even if the building is very good in terms of behavior of structural and non-structural elements, but is located in a dangerous area for problems of the location. The first picture is a big rock that impact on the building from the rock fall. The second is landslides that affect the area of the building. We need to take in account also this problem. This means that in the triage assessment, we have to consider at least 5 main safety issues: the location, site, the structural aspect in terms of global behavior and local problems, non-structural elements, and functionality. This means that the assessment is a multi-dimensional problem that have to take in account everything that can produce injuries or heavy consequences on the occupants, especially on the children. So after this process, the methodology permits to obtain automatically the results that are divided in 3 main groups. The first is the safety situation, the second is the safety upgrading needs, and the third is the status that has been assessed of the school complex. About the safety situation, what we obtain is, first of all, where is located the problem, in the location, in the schoolyard, or in the main building, or in the ancillary building, using a sort of warning level sign that permit to understand where is located the main problems. Then we have what we call the rows of warning or intervention needs that permit to define where we find the criticalities. Remember the previous example in which we assess the structural global, structural local, non-structural elements, functional, and location. This permits to take memory of where the problem is located and what is affected. And we take also in account which type of hazard create this type of criticalities. Some criticalities could be created by earthquakes, some others by wind or flood, and so on. This permits to have an overview of the situation with the level of warning. Just to give you a criteria to read this, if you have the black needles very long, means you have a heavy problem. If you have a middle length, you have some difficulties. If there is no needle, like in this case in the site, there are no warning. This means that the best situation is arose without any needles. This means to have an overview of the situation. Just to have a final judgment, we use the stars that is related to the performance-based assessment. Means that if you have no stars, means that you have some problems in the location. If you have 5 stars, means that all the aspects are very good, and the school could be also used like a shelter if you want. Finally, there is a star that permits to define the multi-hazard, but then
Stefano? We lose Stefano, or
I think you're in mute.
okay, it seems that we lose our colleagues in Italy, so just give me 1 minute, please, until we connect you.
siamo persi.
Just let's wait 1-2 minutes because it seems that we lose our colleagues in Italy. So just 1 minute. Sorry to all the participants for this technical bug, but it's normally on this kind of webinar. So just hold on 2 minutes. We are trying to solve the problem.
Hello?
Go ahead. Yes, we can hear you.
Oh, great. Sorry.
Where we were? Where you finished to hear me?
We were in the safety aggressive needs, I guess.
Okay.
Okay. Can I start again? Okay. So regarding the safety upgrading needs, we divide the action in different actions that are the relocation, the reconstruction, retrofitting, refurbishment, and restoration. This depending of the assessed situation. Related to this safety upgrading action, the methodology permit to have an estimation of cost in terms of ratio referred to the new school with the same facilities. This permits the decision makers to have a sort of criteria of convenience of intervention, taking account if the fact that if the cost is higher than the new construction, this means that probably it's better to proceed with the new construction. But if the cost is low, it's more effective. Go ahead with the retrofitting. All the assessment is also devoted to obtain a sort of overview of the status of the school, because also this is an important aspect for decision-making process in terms of accessibility, maintenance, comfort, water and sanitation, that is very important in some parts of the world, and equipment and aspect of security. This permits to have a global overview. All of this information that are summarized in this slide are the outcomes of the VISUS methodology that can be used by the decision maker in order to create the strategy. Just to summarize, VISUS methodology permit to obtain a multi-other assessment using the technical triage methodology. The process permit an adaptation that Petra Malizan explained later, and use the surveyor, like the nurse, that are trained specifically for using the VISUS methodology, and in order to self-made the assessment, and then through automated and pre-codified algorithms, it's possible to obtain in a uniform way the evaluation that can be used from the decision maker. Decision maker using this outcome can have a graphical indicator that is easy to understand, create some individual reports for each single school complex, to have a collective report for the whole set of schools in the territory considered, and also to have a database and geolocalized maps that can use for the action plan by the decision makers. taking account this data, it's possible to define the strategies. For instance, in this case, there is different possible strategies that say, if I am a decision maker, I say I would like to improve the situation, improving the number of schools that are safe, or I want to increase the number of children that are safe. This is different, the number of schools and the number of people that are affected in the different schools. All the data collected permit to define different strategies in terms of improving safety. You can define, for instance, using the stars, like a priority, the situation that are in a bad situation, but also you can use the data that is related to the budget, demand estimation, in order to use in a more effective way the budget that you have available. You say, I have this budget, I can go ahead with the intervention in this and this school in order to optimize my budget allocation in terms of goal of the strategy. Finally, the last possibility that the decision maker can have through VISUS is if they make the assessment today, the current situation, and obtain the final results in terms of stars and rows of warnings, and also in terms of budget estimation for the upgrading strategies, they can define the action plan. Then it's possible to go ahead with the intervention through the design and the realization through specialists, like in the triage process. But when they finish the works and the intervention, it's possible to check after the intervention if all the aspects are resolved. In this case, if I proceed with the VISUS assessment in terms of post-intervention situation, if I obtain the best situation, you have to obtain 5 stars and no needles in the rows. This permits also to have a sort of control, especially in terms of right investment of the resources in the area that is considered for the assessment. This is more or less the scientific aspect, but now I pass the floor to Petra in order to explain in a more practical way how VISUS works in order to obtain the results.
Hello, good morning. Can you hear me? Okay. In this part of the presentation, I will show you how VISUS works and how it is applied for the assessment of schools within a project. There are 4 main steps for implementing and applying VISUS. Here I list them, then we will see some details for each point. The first step is the preparation, in which the VISUS methodology is explained to the local stakeholders and decision makers. During this phase, the VISUS methodology is adapted to account for peculiarities of the local context. Then, in this phase, there is a training in which local experts and surveyors are trained on how to use VISUS. The second step is the execution of surveys, followed by the automated elaboration of the collected data and the subsequent automated creation of reports for the final development to the decision makers. These phases are the results of many tests during pilot projects in the last years that permitted to improve the process. An important aspect of the VISUS methodology is the knowledge transfer and the capacity building. During the preparation phase, there are 1 or more preparatory meetings which aim at creating local competencies for the self-management of a project. Then the training of surveyor follows. Surveyors are usually students of the last years of local engineering or architecture universities. The training usually ends with the supervised exercise in which surveyors also learn by doing how to efficiently execute a survey, and how to use the VISUS application. Here you can see some pictures from past projects. Training, surveyors have the skills for self-executing surveys. There can be eventually the supervision of a local professor or an expert during the survey if required. The data collected during the survey are uploaded on the database and are ready for the automated elaboration, which is done accordingly to the algorithm illustrated in the UNESCO's VISUS guidelines that Jair previously illustrated to you. During the preparation phase, a person from the steering committee, that is UNESCO and Sprint personnel, work jointly with the local committee, that is person from the country in which VISUS will be implemented. And together, they will work for adapting VISUS to local specificities and to the local language. This then is reflected in the training that is adapted and tailored for each project, even if it is predefined, precodified at the very beginning of the VISUS implementation. And the adaptation also reflects in the survey and in the elaboration phases. I will go in depth on this aspect later on. The survey and the elaboration phases are both executed through the iVisus application that will be illustrated in the following, and that permits both to collect the data during the survey and to have a first evaluation of the outcomes already on the site. As I mentioned, the adaptation to local characteristics is very important and allows to take into account in VISUS for the local specificities of the country, such as, for example, the typical characteristics of the learning facilities. For example, this slide shows some typical educational buildings of some countries in which VISUS was applied in the last years. These building typologies can be identified repeatedly in schools in each country. Through the adaptation, it is possible to take into account all the available knowledge in the country, including in the methodology, the outcomes, for example, of local studies, such as evaluation on the robustness of specific building typologies. For example, many countries have local studies on the fragility curves of specific building typologies proper of the country. This data can be included through a precodified procedure in VISUS. Similarly, it is also impossible to include in the algorithms of VISUS the evaluations derived by local experiences, for example, after past disasters. In fact, very often, detailed information is available for the seismic assessment, as we know, fragility curves or vulnerability curves, while water and air hazard are used less studied in depth. VISUS takes into account the possibility of having different levels of knowledge for the different hazards and implements them in during the adaptation of the project. In order to implement a project, it is important that local people that will implement it are aware of the VISUS characteristics in order to self-manage the successive self-implementation of the project. For this reason, I
guess we are having again a little bit of connection loss, but just give us a minute. We are trying to solve the problem.
Hello?
Yeah, now we can hear you, Petra. Please go ahead.
Yeah. Sorry, where did you
We have an echo. Can you double check your microphone, please, Petra?
hear me now?
Hello?
Is it better now?
Yeah, now it's better.
Great. Sorry, where did you lose me?
Yeah, we were on the side that you were discussing that we're going to give all the elements for the surveyors to implement the assessment by themselves.
Yes, so we will talk about the training, and so that the people in the training is capable of self-implementing the project after the training. So this is the why the training in the preparatory phase is very, very important for implementing correctly the methodology. As I don't know if you heard me before, but in the VISUS methodology, there are 3 modules for the training. One module for decision makers illustrates the essential features of the VISUS methodology, and that illustrates how the results can be used to implement safety upgrading action plans for schools. Then there is a training for trainers, local experts, professors of university, etc., that help to support the adaptation phase and to support the self-managing of the project. And finally, there's the training of surveyors that comprises both frontal lessons and on-site training, in which students learn by doing the surveys. As previously illustrated by Professor Grimas, the VISUS methodology is based on a multi-hazard evaluation. VISUS assesses 3 natural hazards that are water, earth, and air-related. Then it assesses hazards in case of fire, and finally, also eventual threats that could occur during ordinary use of the schools. As already said by both Professor Grimas and by Jair, the VISUS methodology assesses and provides outcomes for every physical component of the learning environment. That's why it considers the main buildings, that are buildings in which there are the classrooms where students stay, as well as ancillary buildings, such as buildings with archives or library, canteen, and so on. Furthermore, VISUS assesses the schoolyard, which is, for example, particularly important in case of strong winds. Indeed, many problems in case of wind are outside the building and not inside a building. Finally, as already mentioned, also the location in which the school is located is assessed in order to account, for example, of the presence of external threats, such as landslide or other hazards. Each type of learning facility is associated to a specific symbol that you already saw in the presentation and that here is summarized. These symbols, as you saw, are used in order to represent the outcomes and to indicate the facility to which each result is assigned. During the VISUS survey, data are acquired for each of these learning facilities. In order to efficiently execute a survey in VISUS, the essential information to acquire is organized following specific survey phases, which have been defined and improved, taking into account experience gained during past projects. The VISUS survey forms were designed in order to guide surveyors during the acquisition of the data, and they follow different survey phases that are reflected in the different sections of the VISUS survey forms, called survey phase 0, SP0, SP1, SP2, etc. The section SP0, the first, acquires the general information that could also be collected during the preparatory desk work before the survey, or that can come from other assessments done on the school using other methodologies. Then the form SP1 permits to acquire information on the location. The form SP2 permits to acquire information on the schoolyard for the schoolyard survey. Then for each building, there are 2 sections, SP3 and SP4, for the external and internal inspection, relatively. The VISUS survey forms are specifically designed to support surveyors. This slide shows how the survey forms are in the paper version. The approach for the design of the forms consists in the use of a graphical language that supports surveyors in recognizing the situation in the learning facilities. Experience showed that the graphical language simplified the work of the surveyors, which are called to look at the reality in the school and recognize the presence of the situation that is depicted in the pictogram, as you can see in the example. Obviously, the training to recognize these pictograms and to understand what these pictograms mean is very important for the good application of the methodology. During the training, specific examples are proposed for each of these pictograms that in VISUS are called observables, and these pictures allow the students to simply understand and recognize the situation. The effectiveness of this approach has been proven during the past application in the pilot projects. Survey forms that you saw in the paper version in the slide before have been very recently also implemented in the tablet-based application that we call the iVisus, that stands for Interactive Visus. This application is intended to make easier and faster the surveys and to reduce the ratio between costs and benefits in comparison with the paper version. Now I want to show you a video on the use of the VISUS application. So I will share my screen. I hope that everyone will see the video. I tried to summarize the most important section of the form and how it used. And for this purpose, I filled some information before doing the video. Now I will start the video where you can see here the forms in the iVisus application. You can see there are the 3 forms for SP0, SP1, SP2 information. And for the general information, you can fill all the required data, for example, the school name, or, for example, you can just put the location of the school you are filling. Now, this is our location, so you have the automatic location where you are, but you can also choose another point, and the coordinates are automatically input in the application. And you can fill all the other fields, for example, also the number of the person there. Some automated support is provided just to fill the data. There's a tab for the hazards that are used for the evaluation of the methodology. So for considering ordinary use, the flood level, the PGA for the earthquake and the wind. Then there's a section of the form for the location, that is the SP1 form, in which all the hazards are collected together, or the OBS, sorry, for all the hazards are collected together. You can see there are the different tabs for the different hazards and the tab for all the hazards. And you can recognize quickly the scenarios in which your situation is located and click and select it. Okay, this is an example of compilation, just very quick. This is the form for the schoolyard, where, for example, you can say, okay, here there are the case of potential hits with protruding objects or sharp objects. We will click this. There's a tab for the status. You can just select the status and show the information without scrolling all the page. And you can fill, as you saw previously, for example, you have information for water and sanitation, for security, example, if the school is full fenced, control access, if there's water, and so on. You have the possibility to sketch the school. Now, I'm not good in sketching, and we will do this. There are space for notes. Okay, and then you can add a building. Here I already added 4, and this is the 5th. And for each building, you can fill the SP3 and SP4 forms. If you remember, it was concerning the external inspection and the internal inspection of the form. Also here we have all the multi-hazard evaluations. You can click on each OBS and assign the values required by the methodology. As you can see, a gray background shows you which elements are selected. You can scroll or you can select each element. This is in case of internal inspection. You can say how many classrooms, number of male toilets, female toilets, and so on for your building. Offices, the occupancy of the school. These are many elements that are in the forms. The forms are the same 4 pages you saw in the paper version. Also here, there's the status concerning the school buildings, considering also accessibility, water and sanitation, and so on. Finally, for each building, you can calculate the outcomes. I want to make you know that these outcomes are calculated automatically by the application. So while you are clicking, and this application works also offline, while you click on the Outcomes tab, the outcomes are automatically calculated, considering the multi-hazard evaluation of the school, but also considering each hazard. So for the ordinary use, fire, water, earthquake, air, and for the status. For the evaluation, in the outcome, you can see the VISUS safety rows. In this case, we filled very few information, so we said, okay, there are no criticalities, and we saw that there is the presence of potential difficulties, for the functionality aspect of this building. And we saw the multi-hazard safety star. In this case, you have 4 stars. That means, what is the meaning of the multi-hazard safety stars for a building? Each hazard has a number of stars assigned, and in this case, there are 5 stars for the ordinary use, for the fire, for the flood, and for the air, while the earthquake has only 4 stars because of these problems in functionality. The minimum value of the stars is 4. That means you have 4 multi-hazard safety stars. At this point, we go back to the school complex, and we can calculate the outcomes for the entire school complex, in which all the data for all the buildings are summarized and showed. You can see a summary of the safety evaluations for the school complex, considering the location, the schoolyard, the main buildings, where you can see the distribution. In this case, we have 4 main buildings. 2 main buildings are green. Let's say there are no concerns. 1 is orange. That means potential difficulties. 1 is red. That means potential severe consequences in that building as worst case scenario. And then the ancillary building. There is the rows for main buildings and schoolyard. That is the envelope of the worst cases for schoolyard and buildings and for ancillary. Then there are the VISUS multi-hazard safety stars that for which I explained you previously the meaning. And there are the outcomes concerning the safety upgrading needs that indicate the needs for what to do in order to improve the safety for the location. In this case, the location was green. That means, okay, there are no concerns, so there's no action required. For the schoolyard, if you remember at the beginning, we said that in the schoolyard there were some potential problems caused by elements on which students could can hit, and so the idea is, okay, you just need very self-action, very little action in order to secure these elements. And then for main buildings, you have the distribution of the actions to apply for each building. This is just a summary. Then there is a summary of the upgrading financial commitment in order to secure the school. This is expressed as a percentage of what to do in order.
You again, we lost you, and we miss you, of course, because we lost you. Let's try it again. Just tell her to get.
Hello, can you hear me? Sorry, Jair?
Yes, we can hear you. Please go ahead.
Okay. So I was saying, should I share my screen again?
Yes.
Please.
Yes, thank you. Okay, I don't need to share the screen. I just keep going with the presentation because,
Exactly.
okay, I was showing you the outcomes and I will just take them, show you them again. I show you how the VISUS application is applied. And this application can be used both for making surveys and for learning how the methodology works. The version for the survey needs obviously an internet connection on the device during the survey, but in a second moment in order to upload and share the data. This version supports the survey, permits to collect the pictures also associated to the OBS. There were a small camera over each OBS, and you can click on that and take the pictures. And the application will upload automatically the data to the VISUS database of each specific project. This version considers the adaptation values defined in the first phase of the VISUS implementation, if you remember that I explained you at the beginning of my part. Furthermore, it is considered the possibility to have a validation phase in which the trainers can control the survey data before the development of the final evaluation of the outcomes and the creation of the definitive reports for decision makers. Then there's the second version, a version finalized for capacity building that is similar to the first one, but that permits to test how VISUS works and permits the users to play with VISUS and to become familiar with the forms, understand how the different parameters, for example, could affect the outcomes and how they are important for each outcome. In this version, for example, also the adaptation values can be modified by the users in order to evaluate their effects on the outcomes. You can say the cost of building a new schools and other parameters that are all described in the VISUS, UNESCO VISUS guidelines. Obviously, this version of the application does not upload the data in the VISUS database. It's self-standing in your tablet. As previously illustrated during the video, the VISUS outcomes can be associated to three main categories: the outcomes on the safety situation, on the safety upgrading needs, and on the status. I stopped the presentation while I was describing you the outcomes that concern the safety upgrading needs, and in particular the evaluation of the costs in order to improve the safety of upgrade the safety of the schools. And finally, there are also outcomes on the status using three main classes, just to say it roughly: poor, middle, and good, that are then specified. The outcomes for the status, as Professor Grimat said, concern accessibility, water and sanitation, maintenance, comfort, and security. The results of the VISUS methodology are collected and made available through a shared database in which users can access with different privileges and see information relevant for their account. The database collects all the VISUS data and all the pictures. It also contains all the outcomes calculated using the VISUS algorithms. Further automated elaboration done starting from this data permits to create for each school an individual report, and for the entire project a collective report with a summary of all the schools and the web map and statistics on the results. In the slides, you can see an example of an individual report created for a pilot project developed in Indonesia. The individual report provides technical details and consists of many pages. The first with a summary of the school main information and characteristics, and the summary of the final evaluation that you saw in the previous slides. And there are 2 pages for each learning facility, for the schoolyards and for each building. These pages provide a detailed and technical description of the outcomes, together with a photo reportage that shows the critical situation identified in the facility. It's important to note that these individual reports are created after that the VISUS survey data are uploaded on the database and are eventually validated by a trainer. Then there is the collective report for each project that provide a summary of the outcomes, considering also some statistics on the data, and for each school a summary panel with the very essential information for each school. Then web map permits to investigate the outcomes, considering also the position of the school in the territory. Each marker, in correspondence to the schools, shows the multi-hazard safety star assigned to the school, and then by clicking on the marker, as you see in the picture, a pop-up opens to show some additional information and provides a link to download both individual and collective reports. Obviously, there are different accesses for to access to this map and see the data. So I will pass the floor to Jair for the final step. Thank you very much.
Thank you, Petra. So I'm going to go just to show you very quickly some of the examples. One of the examples is the last implementation that we developed in Mozambique, just for you to see how this applies to real life. And then we will go to the questions that I guess that is the most interesting part of that. We have already 3 questions that I guess that are very, very important to be raised. If in the meantime you have more questions, please do not hesitate to write your questions, and then we want to share it with the whole group. So, just to tell you, we have implemented this methodology already in 7 countries, starting from Italy, where the first implementation was done in 2009. Then we did El Salvador, where also we applied this methodology only for the seismic hazard. But after that, we understood the need that we, as I was mentioned on the example of Haiti, that we need to go in a multi-hazard approach, because decision makers need to have the information not only specific for a specific hazard, but in general for all of the hazards, how are it impacting the schools. So then we prepared the first implementation in Laos together with Save the Children, and then in Indonesia, in Haiti, in Peru, in Mozambique, and this is where we have the 7 implementations of VISUS. So the last 5 has been on multi-hazard perspective, and this is what make us to validate all the idea and the technical background of VISUS, and that allow us to actually launch the methodology last year officially, after being peer reviewed by more than 30 technical institutions worldwide, including the Building Research Institute of Japan and many, many other important institutions on engineering. So, as I told you, one of the main outcomes that we have on the UNESCO VISUS Mozambique was the training of decision makers, so to understand how they can really get to use this information. We train trainers because the idea is that every single country can have the sustainability to do continuous and periodical assessments of that. And those trainers were normally located at the Minister of Education or Minister of Public Works, so high technical specialists on those ministers, but also in the universities, notably professors of the faculties of civil engineer or architecture on those universities. And then the surveyors that can go also to the question that one of the participants have, is like who could be qualified to conduct the survey. So what we have done is we have people at the Ministries of Education or at the Ministries of Public Works that actually their work is to implement surveys in the schools. So we can use already those capacities that exist at the ministries. But also knowing that we're going to go to a large scale of schools and that the capacities of those ministries are very limited, we believe that this methodology, and has been proven to be efficient, can be applied by trained surveyors that normally are last year students for civil engineer or architecture in those universities, but also, construction trainees from technical and vocational institutes. So with that, you can increase the mass of surveyors that has a real, a basic background of engineering aspects, and that with the VISUS methodology can really go and collect the different elements and characteristics that the methodology is asking to provide. So in a way, the methodology itself produce the judgment, but the surveyors will have all the elements to characterize better each of the buildings that has been designated. So with that, I'm trying to reply also the question of the colleague who was asking who will be qualified to conduct the survey. So then we did, after the training phase, the capacity building in order to transfer the technology, to transfer the knowledge to the specific country. We assessed 100 schools in a multi-hazard perspective, 100 schools that were about 869 school buildings, more than 500,000 students in these 100 schools. More than 250,000 students on these schools. And we developed all the reports for all of them. In the adaptation phase, what we did is we incorporate all the information that already the Ministry of Education, the Ministry of Public Works, but other institutions like the National Disaster Management Agency has. Do you hear me? Petra, do you hear me? Yes, yes. Okay. Okay, if you hear me, it's okay. So maybe for the colleagues that couldn't hear me, if you can update the website. Okay, good. So I will continue. So we took all the information about typologies that has been produced by the country, and this we are incorporated in the methodology. For those buildings that we have fragility curves, we incorporated in the adaptation process. Also, we evaluate all the hazards. So what are the hazards that will affect Mozambique? So we see that they have tsunami hazards, that they have hurricane hazards, that they have earthquake hazards, flood and drought hazards. So all of these hazards were incorporated on that. We are not going to adapt the methodology for tsunamis in countries like Bolivia, where you don't have any kind of access to the sea. So this is what is important, the adaptation process. Then we prepare all the elements. We adapt the methodology to the IT tools that we had before and that we have improved and that were presented now by Petra in order to collect the data. As I mentioned, we perform the trainings and we perform the survey with those students of last year university of the Universidad Eduardo Mondlane, the Faculty of Architecture in Mozambique. And with that, we select all the 100 schools that were already assessed in the Maputo area, and we have 100 individual reports per schools where you have the different issues that every single school will have. So as you can see, you can click on a GIS format on the specific schools, and if you follow the link, you will go directly to the individual report of that school, which is very important because like that, this information can be linked into the education management information systems and in a way can be used for planning on investments on improving the quality of the learning facilities, but also if we think twice and ahead, also for post-emergency response, because like that you have an information about what could happen on that specific school and if it really happened and how you can interact that. I will go back to the post-disaster because this is something on which we're going to go later on. It's the next step for us in the future. We developed the collective report, and in that collective report, we informed the Minister of Education about what was the most typical school building construction. We informed also what were the sum of ordinary problems that we found there. So that you see, there are what I was mentioning at the beginning, they are not on the structure itself, but are in the safety. So as you can see, there are issues. If you see a kid running here on this green area, if he fell, this can produce a lot of problems and injuries to those specific kids. So with practical solutions that can be self-implemented, schools can become safer. But also we realized that there were some weakness in the structural capacity or on the load capacity of the schools. So we saw a lot of problems in connections. We saw a lot of problems on cracks. We saw a lot of problems also on the material of specific classrooms. And we saw many problems, as I was mentioned, on local structural problems that can make that roof structures can collapse. So all of this information was given to the Minister of Education with the necessary or with the potential strategies that they can use. Gary de la Pomaré, he was mentioning that he has a specific case in Nepal where a wall was falling. So this is, you can see already one of the examples on which when we assess these kind of situations, on which one there is a wall that is not a wall related to the building, but is a wall related to the school itself. and that normally when we see engineers will not put attention to that. But the idea is, as we are trained to go on the safety issues, we check also this part. So this is one example of what Gary has just mentioned in the chat about the wall falling there. Also, we discovered that there was the presence of asbestos in several schools, which is a health problem there in Mozambique, and a lot of issues concerning waste management that can generate, for instance, fire. So it's something that they have to put attention. Also, for a strong wind, we also saw some problems with the connections. So we see many issues that really they can start checking. So some of the recommendations that we give to Mozambique was to launch a national program for schools assessment, so to scale up this methodology to the national way. So this is something on which one UNESCO now is negotiating with the World Bank, trying to see if in Mozambique they can scale up to the whole country. Implementing a prioritization plan for rehabilitation, retrofitting, and replacing schools. Reinforce the national database of schools with more detailed information on safety vulnerabilities, that this is something that they can link to the education management information system, including creating the database of typical damage, because that will help also to try to analyze what are the different strategies that can be implemented in a more efficient way. Improve information on cost details, because the information on cost details in Mozambique is very, very preliminary. So we encourage the government and the Chamber of Construction to start taking more details on cost information, and to plan for continuous monitoring, financing, and oversight of ongoing facilities maintenance and safety, because we realize that one of the big issues is not a problem of on the way that you build or you retrofit, but it's in the way that you don't maintain those schools. And then we give a recommendation about involving parents and communities, because we believe that through the school safety strategies, we can also get to the community and to those buildings that are not schools, but that are very vulnerable on those communities. So as I was mentioned before, this methodology has been peer-reviewed by more than 30 institutions worldwide, most of them technical institutions, as you can see, like the National Research Institute of Astronomy of Egypt, the Technical University in Havana in Cuba, the Tokyo Polytechnic University in Japan, universities in Chile, in China, in Turkey, many of them that really have been peer-reviewed and criticizing in a very positive way and giving solutions about how to make the method very good, very efficient, and very solid. So it's not only the University of Udine and UNESCO who came up with this method. It's a method that has been getting a lot of feedback from technical institutions worldwide, and also that feedback has been incorporated on all the pilots that finalized with the VISUS implementation. Saying this, so we have for the upcoming year, we are negotiating pilots. They want to have for sure a pilot in Dominican Republic, and we are in negotiations with Panama, Costa Rica, Argentina, Saudi Arabia, Jamaica. We're going to do the first pilot, and we are in negotiations for scaling up this at the national level in Peru, in Haiti with the Adaptation Fund, in El Salvador, in Indonesia, and in Mozambique. So we're going to go to scale up, and the idea is that we can also get the support of all of you partners in order to implement this methodology and bring these capacities worldwide with your support. So we would like to, before finishing, I would like to thank you, the supporters, so the people that really provide the necessary funding for us to develop this methodology and that has really trust us on this, like the Minister of Land Infrastructure and Transportation of Japan, the Indonesian Funds in Trust, so the government of Indonesia, the Humanitarian Aid and Civil Protection of the European Union, the United Nations Trust and Funds for Human Security, and different partners of the Global Alliance, such as Save the Children, the World Bank, and GFDRR. All of them that have been contributed with funding and expertise to make this methodology really a success, and we would like to continue improving the methodology through continuous application of ease. Now what we are planning is to try to go worldwide, so through GADRRRRES members, so for instance, colleagues of Save the Children, of UNICEF, of the World Bank, of UNESCO worldwide. We would like to, for you, that you understand that this methodology is for you supporting the Minister of Education, so you can incorporate this in your planning and in all of the elements that you would like to propose to governments. And we will be there to support you technically in all of the programming that you would like to do, including the VISUS methodology. So now I would like to pass the floor to the final discussion. I'm going to start with some of the questions that they have been already raised. I don't know if we're going to put it in the mode QR. Lucille, if you can help me with that.
Yes. So first, thank you very much all for the presentation, which I think was very rewarding. Just to let you know that before we start the question and answer session, we will follow up with this webinar with an email including all the contact information, the web links to the VISUS guidelines, the YouTube webinar link, as well as other information items related to this webinar. Now, we do have a couple of questions that came through during the webinar. So I'll just put up the first one. So the first one is from Gary de la Pommeraye. I have a perfect example of an orphanage school here in Kathmandu that the support wall of the playground collapsed with a 60 feet drop at 80-degree slope. The buildings are reasonable, but the grounds were not assessed for support. So maybe Jair, if you want to answer.
Yeah, this is one of the examples that I was showing also in the picture of Mozambique. So that Gary already presented is the same, you know, like sometimes realize that buildings are very well built, that follow building codes, that the site selection is good, but the problem is with the environment around those schools. And for instance, as Gary has mentioned, you know, the playground wall has been collapsed. So this is something that can put in danger the safety of kids. So this is something that we have taken into consideration because we believe that the safety is not only on the walls, but is also on the environment and in the green areas that where the kids are normally having a normal, regular day.
The second comment from Gary as well is the need to be careful not to go down the route of targeting the most children, as this will prioritize only the larger, usually better built schools and leave isolated the remote, smaller, very vulnerable schools. Governments might target easier, larger number of children's schools to create a better impression.
Yeah, this is something that, as Professor Grimas was mentioning at the beginning, what we want to do is to provide all the elements of information for decision makers to take the decision about how they're going to proceed on the strategy. We know that, as Gary is mentioning and is trying to make, there is a lot of politics behind these things, but our function is not to tell the politicians or tell the people of the ministry what they should do, but to provide it with the elements that they need to consider in order to take the better decision. Saying this, for instance, we have the example that Gary has presented here in El Salvador. In El Salvador, we realized we assessed 100 schools, some of them that were isolated and remote, and some of them that were in urban areas. And with these elements, so if you have the elements of the assessment, the government could take a different decision that maybe we expect. And the decision that the government had at that moment, after the evaluation, after the assessment, was to close those remote schools that were very, very that present a lot of problems in terms of safety, and provide transportation services for those remote areas to the best school that was closer to that one. So they implement a lot of funding on retrofitting big schools with a big offer of students, with a big demand of students, but taking into consideration the problems that the small and remote had. So the solution before building a new school on the remote or isolated areas was to provide transportation to a better school while building a new schools on those areas. So this is something that I guess is like how governments can take into consideration these elements, and this is something that also we try to, when we talk to decision makers, we try to tell them that they need to have a global picture about the issues and try to provide not only typical and common solutions, but also to alternate solutions like that one of the transportation.
Thank you, Jair. Then we have a comment actually from Pablo Campos, who say that he fully agrees on the relevance of the adaptation to local characteristics, but not just the geographical climate ones. We should also include the cultural ones, especially the architectural ones.
We are completely agree with this comment from Professor Campos. This is why we, in the adaptation process, we try to understand as much the kind of typologies that we will see. There are many typologies that are very related with cultural constructions. For instance, in Italy, we have a lot of buildings that have a lot of cultural significance for the Italians, that maybe they are after the assessment we realize that retrofitting or implementing actions on those schools will be more costly than the cost of building a new school for the same quantity of people. But as we say, we give all the elements to the decision makers, also highlighting that this building has a cultural value for the community, and that so then the decision maker can decide that, like, even if it's more expensive to intervene this building, but knowing that has a cultural value for the specific community, we will invest that money even if it's more expensive, because we would like to preserve the cultural identity of that. Similarly, we also try to check try to see if there are some kind of fragility curves or that can be similar to some vernacular architecture or some elements. We are also trying to incorporate some kind of efficiency on energy in order to be sure also how the school is facing climate change adaptation and etc. So it's a very important comment, but this is something that, Professor Campos, I can reassure you that we have been taking into consideration.
Who would be qualified to conduct this survey? We answered already a little bit this question, so maybe I will just move on with the next one from Ardito. How and when we can start to test the use of VISUS with automated evaluation? This maybe I will leave Petra and Stefano answer the question.
So before Petra and Stefano, just to say, Ardito, our idea is like, please get in contact with us, because at this moment for the automated VISUS evaluations, we're going to have two kind of formats. So one that is going to be used for capacity building, so that you can test and play with these automated VISUS evaluations without producing the real report, because we will use this for more capacity building elements. But also, when we start developing an application and a real implementation of VISUS, then we're going to have the valid version of the automated evaluation, because we want that people use it for understanding how it works. So, but that will be, please get in contact with us. But then when we do the implementation is where we're going to use the real final and validated versions that incorporates the adaptation of each of the elements for that specific country. I will pass the floor to Petra and to Stefano that maybe can elaborate more on this.
Just to say that we are working on the platform now, taking account all the experience of the pilot project. We are more or less at the last step of the VISUS player, we call player, that permit to obtain automatically the outcomes. And in our work plan, now we are working on the platform for the application. But everything is working like in the past through the process of VISUS. Now we are trying to automatize everything in the platform, but we are work in progress. I think some months more in order to finish all the process. But what I want like to stress is that we plan to use a test phase, for instance, with Ardito, that's already done the survey in the pilot project in Indonesia, in order to have also the feedback of the platform before to share with all the people that are interested in the implementation.
So we're gonna go to the next question.
Which is it possible to contextualize the online survey assessment tool?
Yes, it is possible, because one of the main steps on the development of the VISUS methodology is the adaptation process. So we need to contextualize not only the online survey assessment tool, but also we contextualize the training modules that we give to decision makers, to trainees, and to surveyors. We contextualize the whole elements to be sure that we are seeing the typologies that are specific for that context, the hazards that could affect the schools on that specific location, and etc. So we contextualize is part of the question. I see that we have another question also from Jin Chen about this. So yes, we don't believe on a one size fits all. So this is why we have the standard methodology, but before implementation, that standard methodology gets adapted to the local realities of each specific context. So it's embedded in the methodology itself.
Thank you, Jair. Then the next question from Florence Le Paulmier is that this diagnostic tool take into account the level of preparedness in place? I'm thinking, for example, as a school emergency plan.
So thank you, Florence, for this question. As I was mentioned at the beginning of the presentation, we have the comprehensive school safety framework where you have the 3 pillars. A school emergency plans is more focusing on pillar 2 about disaster risk reduction, disaster risk management at the school level. We are trying to provide elements that schools later on will take into consideration in developing the school emergency plans. But our focus on the VISUS methodology is to go to try to understand the learning facility, how can affect the safety of kids or not. So this is another element that, for instance, the self-assessment methodology that has prepared Save the Children provide more elements on these areas. We have the 3 pillars of the school safety framework, and we didn't want to combine all of them in only one assessment, because you will need different specialists for different kind of assessments. So you will, concerning a school emergency plans, you will need another kind of views, and you will need to do another kind of survey that is different to the survey that you do to schools, to the building itself. So it's important for us. We have also tools that has been developed in this specific area, but the VISUS methodology will focus on the learning facilities itself.
Great, thank you, Jair. And sorry, I have to rush a little for the next questions. Yes, Stefano, please.
I only very, very little thing about the emergency plan. The outcomes of VISUS permit to define the potential scenarios of criticalities that could be faced during the emergency process. It permits to have an overview of what we can face during the emergency. This is the starting point for the emergency planning design in the preparation.
Thank you, Stefano. Then the next comment from Pablo Campos, which mentioned the special relevance of the involvement of the communities, parents, and relatives together with local administration or delegates of regional and national ones.
Yeah, this is something that we highlight when we do the training for decision makers, the need to communicate what we are doing to the community, because it's a way in order also to reach not only the school community, but other people at the community that also will start assessing their own houses and their own buildings in order to see if, if they are similar to the school. So we incorporated that, but also when the strategies are part of the assessment, which they can have more like a supervision role or a companion role, then when we are planning the implementation of strategies, we believe since the beginning, and this is something that, for instance, on GADRRRRES we have developed, some guidelines about how to do community-based safe school construction, and on which one we would like that the community provide their views as well on the strategies that will be implemented and on the better way to do it. Because sometimes the communities for us are the best inspectors. They are the people who understand the plans and that they can follow the plans if we are really using the necessary material, the quality of the material that has been decided, etc., etc. So this is why we believe that this is very important. In the assessment parts, we involve them in order to know what we are doing, in order to know how it's important to also to evaluate the infrastructure also for them to bring them home. But we believe that in the implementation process of the strategies is where they're going to have a bigger role for this.
Stefano, would you like to add something?
Oh. It's okay, I agree with Jair.
Great, thank you. And the last two questions, and then we will need to close, unfortunately, from Jin Chen. The question is, do you use the same platform in different countries, or are they adapted according to different countries' needs and context? This, I think, we covered a little bit. And the second question is, where do you keep the data of the survey, since about schools detailed data? Have data security been a concern of any countries you've worked in? Yes.
So, yeah, it's a very pertinent question, Jin. All this information belongs to the Minister of Education of the countries. So with the automatic reporting, for instance, because we have, this is something that we already have been discussing, for instance, in countries like Cuba, in countries like Mozambique, on which ones the Minister of Education would like to have this data and they will have to disseminate this data. So when we are doing the piloting phases, so we have the automatic control that has been developed in the University of Udine. But when we are scaling up these things, what we do is the automatic control tool will be installed at the Ministry of Education itself. But that means also that we need to put into consideration other elements. It's about the quality control of those reports that have been automatically produced. And this is why we believe that in every single country, it's important that you have a VISUS focal point and a national committee for VISUS implementation that will be follow the implementation of this and that will check the quality of the data that has been collected. So the idea is that all of this automated reporting would be installed on the Ministry of Education or on the Ministry of Public Works or on the National Disaster Management Office, depending on the setup of each country, and the data belongs to the countries and only to the countries.
Thank you very much, Jair and Stefano and Petra, for answering the questions. I'm sorry that we need to close this question and answer session, but if you have any more questions, I would like to encourage you to write them here in the chat box and we will follow up on them. You can also reach out to us via the GADRRRRES@gmail.com email address, or you can also write your questions down in the discussion in the community of practice Safe Children, Safe Schools, and we will follow up there. Just before we finish, we are interested in making webinars that meet your needs. So we would love to hear from you on how you thought this webinar went. So please fill out the survey just that I'm going to share in the chat box here. So we have two questions. The webinar objectives were met. So you strongly agree, neutral, disagree, or strongly disagree. And the second question is the webinar content will be useful for your work? So strongly agree, neutral, or strongly disagree.
Just before finalizing, I see a comment from Dr. Muhammad Amin Sunardi from the University of Veteran Bangun Nusantara in Central Java. So yes, VISUS was implemented in Jakarta. So if your university is interested, I will strongly recommend you to get in contact with the UNESCO office in Jakarta with Ardito Kodijat. He is part of he has been chatting with us, but please contact us and we can give you his details and we can try to see how we can involve the university on further implementation for Central Java. As we say, we strongly believe on the involvement of universities and academics in the implementation of VISUS, because we believe that this is the only way that we can bring sustainability to the VISUS implementation, but also about school safety assessment. And we believe on the necessary role of coordination between governments and scientific institutions in order to reach the targets of the 2030 agenda. So please, Muhammad, don't hesitate to contact my colleague Ardito. Well, we see all the comments in the survey about strongly agree. Juni was asking about where you can find comprehensive and complete information on VISUS. All the methodology is online, so you can go to the website of the of UNESCO for publications that is called UNESDoc, and there are the 3 different volumes of the methodology. For the implementation of pilots, you're gonna find some of the reports available online. Others are not online because, as I was mentioned to our colleague in China, these reports go straight to the Minister of Education, and it's the Minister of Education who decided if they make it available to the public or not. So for the pilot implementation and the reports that of those countries that we have done it, it's case by case. But about the methodology, you can access to it to the UNESDoc website.
Do not worry, we will send anywhere an email after this webinar to all of you with the links and everything. Right, so Dr. Jair Torres, Professor Stefano Grimas, and Dr. Petra Melissa, thank you so much for taking the time to present today. I believe this webinar was truly interesting and useful. And thank you also to all of you who have joined us today, made the time and contributed to a great discussion. We are really looking forward to continuing the discussion with you via exchange of emails, as well as via the community of practice, Safe Children, Safe Schools. And please also do look out for some webinars dedicated to school safety and disaster risk reduction coming up soon. Thank you very much. Bye-bye.
Bye to everybody, and really thank you for being part of the webinar. And we hope to see you very soon on all of the webinars prepared by GADRRRRES. Have a nice day and a nice week.
Bye.
Thank you very much.
Bye-bye.
Bye.